Hey guys, it's Mrs. Bernal here, and I want to talk to you about section 10.3. I'm sorry, I don't know why this is. There we go. All right, we're talking about two things in this section, and we're talking about theoretical probability, which is, in theory, what should happen. So if we're looking at the number of favorable outcomes out of number of possible outcomes, that would be the theoretical probability. So let's say we have heads or tails on a coin. If you only flip it once or 10 times or 20 times, you should expect that half of the time, right, if you want to get heads, the theoretical probability of getting heads is, that's your favorite outcome. That's only one out of two possible outcomes because there's heads or tails on any coin that you have. So that would be the theoretical probability of flipping a head or flipping a tail. All right, so let's take a look at the example in the book. We have these three blocks. They spell explore. And so it says you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Well, how many vowels are there? 1, 2, 3. There are 3 vowels. And there are a total of 7 letters that you could possibly get. So the possible outcomes is 7. This is your favorable outcome of what you want to get, which is the 3 vowels. So then the probability is 3 out of 7. If you were to divide 3 by 7, you would get 0.42, which is 43%. So that is theoretical probability. So what is the possible, you're figuring out your probability based on what should happen, and figuring out like your chances, for example, winning a game, etc. All right, so experimental probability is different in that it's based on, and let me go back here, what actually happens when you do the experiment. So here's our definition here. It's the probability that is based on repeated trials of an experiment is called experimental probability. So the number of times that the event occurs divided by the total number of trials. So let's say you flip a coin. Let's say I flip a coin 10 times, and I want to know out of 10 times, how many times did a tail occur? So let's say I do that 10 times, and 6 times I got a tail, and I did it 10 times. So I looked for tails, okay? And like I said, let's say out of 10 times, I got tails 6 times. So 60% of the time during my experiment, I got a tail. So that would be the experimental probability. So you have 2 definitions that we're working with. And you guys can pause anytime so that way you can write the definition. But so we're really looking at experimental probability. So what's the probability of a favorable event happening out of the total number of trials? So that's based on an experiment. Theoretical probability is what should happen. And there's our definition there. Okay, so you can pause, like I said, anytime you want to. So that way you can write those definitions down. All right, so let's take a look at one. I want to show you an example of a fun experimental probability. Okay, so we're taking a look at flipping heads or tails. Now, the book describes something called relative frequency, and that is just really saying, okay, so the number of times your event occurs over the total number of times you conducted the experiment would be your relative frequency. So really, it's the same thing as your experimental probability. Okay, so if I flipped a coin here, and I'm flipping, and I do this out of 20 times. You could actually pause and do this. Take a coin, any coin, and flip it 20 times and see what you get in terms of your experimental probability, what we just talked about. Now, theoretically, if you have only 2 choices, heads and tails, what should you get out of 10 times or out of 20 times for flipping heads? How many times should you get flipping tails? theoretically. We're talking about theoretical probability. Well, since there's only 2 choices, really you should get 10 times you would flip a heads and 10 times you would flip a tails. So that would be your theoretical probability. So theoretically, if we were to write that down, right, like what's the theoretical probability of this event? Theoretical, let's see if I spelled that right. I don't know. All right, should be out of 20 times, I should get tails. And I should flip heads. Okay, so I want you to pause right now and test that. How many times, and you just use tick marks, right? So you flip, you get a tails, just put a little tick mark, little dash mark, okay? And then we're going to see how many times did you get? What was your experimental probability? Okay, so do that, pause and go ahead and do that. Okay, so I did the experiment and I actually had a penny here and flipped 9 out of the 20 times was the tails, and heads I got 11 out of 20. So you may be asked, okay, so is your experimental probability, so that was theoretical, and your experimental probability, are they close? Yeah, they're pretty close. That was our experimental probability. Okay, so are they close? Yeah, they're really, really close. And you guys can hear my dogs probably arguing in the background. So very close, right? So if you have an idea of what it should be and you do your experiment, it makes sense that this was so close. Sometimes people do this and it's dead on, 10 and 10. Sometimes it's 8 and 12. But you can figure out what the percentage is. So my experimental probability is 9, right? I'm going to go divided by 20. 9 divided by 20, and that equals 45%. So 0.45, we change that to a percentage, 45%. Then 11 out of 20, 11 divided by 20, 55%. So in my experiment, we're talking about the experiment, 45% of the time I flipped a tails and 55% of the time I flipped a heads. And it's very close to my theoretical, which should be 50% of the time you would flip a tails and 50% of the time you would flip heads. So big idea for section 10.3 is we're looking at theoretical probability, which what should occur given what we have, and then the experiment, once you do it, what did you actually get? And most of the time it's very close, very close. All right. So I'm going to pause there. You go ahead and pause and make sure you have all that written down. And if you want to try the experiment again and see if you get close to your theoretical probability, you can. All right, the last thing I want to talk to you about is just comparing experimental and theoretical probability. And I want you to take a look at this bar graph. How do we read this bar graph? So we have a number cube, 1 through 6, right? A dice. And this person did an experiment. And 48 times rolled a 1, 53 times rolled a 2, 50 times rolled a 3, 52 times rolled a 4, 49 times rolled a 5, and 48 times rolled a 6. So if you look at all of those numbers, that's the total number of times the person rolled or flipped the cube, however you want to say that. So if you add these up, that would be the total number of trials. And when you do that, you can see here in the example, the trial, it was the total times of 300 rolls, okay, 300 rolls. So your probability, your experimental probability represented in this graph here. So for example, is right here. So your total number of trials is the bottom number, right? 300. And so here given, so the number of times an odd number was rolled, you would have to take the sum of 48, 50, and 49 because that's the times That's the number of times that those odd numbers were rolled. So when you take the sum of those, it's 147. So the probability of rolling an odd number, 147 divided by 300, and it's 49%. So think about that. There are 3 odd numbers on a dice. There are 3 even numbers on a dice. That is half and half. So your probability of rolling either an odd or an even is really 50%. So the question is, does this experimental probability compare to the theoretical probability? And the answer would be yes, because the experimental probability was 49%, and theoretically it's 50% is your odds of rolling an odd number or an even number. So there again, comparing experimental probability with theoretical probability. So I just want you to make sure you pause and write those terms down and understand experimental is based on the experiment. What were the actual numbers once you did your experiment, once you tested, right? You had 300 trials in this rolling of a number cube. And then if you think about theoretical, like what should happen in quote unquote theory, well, if you have 6 numbers, half of them are odd, then that means 50% of the time you should roll an odd number. Same thing with even numbers. There are 3 even numbers, so you should roll an even number 50% of the time. All right, so your practice this week will involve those 2 types of probability along with some other things that Miss Chapman and Miss Thomas provided for you in their videos. So have a great week. Remember, June 1st is the last day that you can turn anything in for credit. And if you have any questions, please contact your teacher. Have a great one.